Hello and welcome. Today we're jumping into a huge paradox in public health. You see, our most valuable data is also our most private. So how in the world can we use AI to learn from all that data if we're not actually allowed to share it? So public health has this massive data problem. And it's not that we don't have enough data. Believe me, there's plenty of it. The issue is that the most valuable, most critical information is locked away in thousands of different places. Think hospitals, state health systems, private records, you get the picture. And for very good reasons, legal, privacy, most of it can't just be packed up and moved. So that leads us to this really fundamental question. The solution here is actually pretty brilliant. It's a total shift in how we think about the problem. Instead of going through all the trouble of bringing all the data to one central place, what if we did the exact opposite? What if we could send the AI model to go visit the data where it already lives? And this right here really shows you that core shift. The old way, the traditional way, was all about gathering these massive data sets into one single location to build a model. But federated learning, it completely flips that script. The data stays put, nice and secure behind each hospital's firewall, and instead we send the model on a trip to learn from the data right there on site. This whole technique is called federated learning. And what it does is let a whole bunch of organizations collaborate on training one shared model. But, and this is absolutely the most important part, they do it without ever having to exchange their raw, super sensitive patient data. The model gets smarter and the patient data stays private and secure. It's a win-win. Okay, so that's the big idea, right? But how does this actually work in practice? I mean, what are the mechanics of teaching a model that has to travel all over the place? Let's break it down step by step. It's actually a pretty straightforward cycle, often called federated averaging. First up, a central coordinator sends out a basic starting version of the model to every hospital taking part. Next, each hospital trains that model using its own private patient data. Now, here's the magic trick. Instead of sending any data back, they only send back the learnings. We're talking about the mathematical updates to the model. The coordinator then gathers up all those updates, averages them together, and creates a new, improved global model. And then you just do it again. You repeat that cycle over and over until the model gets really powerful and accurate. Now, this approach is incredibly powerful, but let's be real. It's not a magic wand. To do this responsibly and effectively, we have to talk about the very real challenges and the absolutely essential guardrails you need to make it all work safely. You know, just because you're not shipping raw patient records around doesn't mean there's zero risk. If you're not careful, those model updates could, in theory, leak some information about the data they were trained on. So while this approach massively reduces risk, it doesn't just eliminate it all by itself. So any real-world system is going to use layers of protection. You've got secure aggregation, which is kind of like a digital lockbox. Everyone puts their updates in, but the coordinator only gets the key to the final combined result, not any single person's contribution. Then you have differential privacy. Think of it like adding a tiny bit of statistical noise or fuzziness to the results, just enough to make it mathematically impossible to reverse engineer and identify any single patient. And, of course, on top of all that tech, you need rock-solid governance and auditing. But you know what? Maybe the biggest challenge isn't even privacy. It's statistics. The data at one hospital is just, well, it's different from the data at another hospital. In the machine learning world, they call this non-IID data, which is just a fancy way of saying it's not all the same. Each hospital's data set might be teaching the model slightly different, maybe even conflicting lessons because they have unique patient populations. For instance, let's say Hospital A serves a community with a really large elderly population. Okay, so a model trained there is going to get really, really good at spotting conditions that are common in that age group. But then you look at Hospital B, and maybe it serves a much younger community. Its model is going to learn completely different patterns. And this difference, it actually highlights a huge opportunity. A single centralized model might just average everything out and kind of hide these health disparities. But a federated approach can actually be designed to spot them and maybe even help create models that are tailored for these different communities. So with all these complexities, why is this so incredibly important for public health? I mean, why go through all this trouble? Let's connect the tech back to the real-world problems it can actually help us solve. The potential applications here are they're game changers. Think about trying to predict patient readmissions or the risk of a disease outbreak. Those are problems that need a view across entire regions, not just what's happening in one hospital. Or better yet, imagine building an AI model for a rare disease. One hospital might only see a handful of cases a year, not nearly enough to train a model. But by pulling the learning from dozens of hospitals, without ever pooling the actual patient records. You can build a powerful model that benefits everyone. So what's this single most important thing that decides whether a project like this succeeds or fails? Well, you might be surprised to hear it's not actually the technology. Federated learning is the perfect tool for a very specific job. It shines when your data is sensitive, when it's scattered all over the place, and when you need both huge scale and lots of diversity to build a good model. But that last piece on the list, that's the most important one: a shared goal and a solid governance structure. That is the real key to making it all work. And I really want to let that sink in, because without good governance, clear rules, real trust between the partners, a shared mission, you don't really have a federated learning project. What you have is just a coordination problem. And technology alone can't solve the human challenge of trust and collaboration. So the big idea, when you boil it all down, is pretty simple, but it's also really powerful. Train together. Share the learning, not the data. By keeping all that sensitive information local and secure, we finally have a practical path forward in a world that's full of data silos and privacy rules. And that really leaves us with this final thought. Federated learning is one potential answer to a question that is becoming more and more critical every single day. In a world defined by all these data silos, how can we possibly collaborate and get smarter together? And that's our explainer for today. Hey, if you found this interesting, hitting that like button and subscribing really does go a long way in helping us break down more topics just like this one. Let us know what you thought in the comments below. We'd love to hear what you think. And even more importantly, what complex topic should we tackle next? Let us know in the comments. Thanks so much for joining us.